Why did Einstein believe that time changes as an object moves faster? And why is our understanding of time merely a deeply ingrained illusion? For thousands of years, people have used time to measure the cycle of day and night, and to describe the passage of moments. Time accompanies us every second of our lives, yet we cannot truly define what time actually is. As early as the 17th century, in the classical physics system led by Newtonian mechanics, time and space were considered to exist independently, with no inherent connection between them. This is the concept of absolute spacetime. Newton believed that time flows at the same rate in every corner of the universe, and this idea was widely accepted for a long time. In everyday experience, time is seen as absolute and fair, passing equally for everyone. But a century ago, Einstein's theory of relativity emerged, completely overturning our understanding of space and time. One key idea of relativity is the concept of time dilation. Imagine two people with perfectly synchronized clocks. One of them travels through space at high speeds along a different path. When they reunite on Earth, their clocks will no longer match. The person who stayed on Earth will find that time has passed much faster for them compared to the traveler. Time dilation describes the relationship between time, space, and matter. Simply put, the motion of matter affects the space-time around it. The faster an object moves, the slower time flows for it. In general relativity, time is not only influenced by speed but also by gravity. Einstein saw time and space as an inseparable whole, what we call spacetime. Our universe is like a vast fabric of space and time, where objects warp the space-time around them. The greater the mass of an object, the more space-time bends around it, effectively stretching the path of time. This is why time slows down near black holes. In the movie Interstellar, when the characters land on the planet near a black hole, they encounter a mishap and stay for a few hours. But when they return to the ship, 23 years have passed, and their companion has aged significantly. This scene is based on the time dilation effect predicted by general relativity. The flow of time can be imagined as a series of snapshots, with every event being part of a collection of these snapshots. From the Big Bang 13.8 billion years ago, to the formation of the Milky Way, to the birth of Earth 4.5 billion years ago, to the rise of dinosaurs, all the way to the present and even the future, every event that has happened or will happen already exists within spacetime. This challenges our conventional understanding of time's flow. It suggests that our past, present, and future may all be illusions. Imagine this. At exactly 12 o'clock noon, a cat jumps from a window. A pigeon takes flight in a distant square. A meteor crashes into the moon 380.000 kilometers away. And a star explodes a few light years away. Countless events are happening simultaneously across the universe, all forming what we perceive as the present moment. We can think of this as a slice of spacetime, with each slice changing continuously, creating what we experience as the flow of time. But when we introduce motion into this spacetime, we realize that time's passage is merely an illusion. Suppose an alien exists 10 billion light years from Earth. If both you and this alien remain completely still, you share the same spacetime slice, meaning your time is synchronized. But if the alien starts moving away from Earth, their motion slows their time relative to yours. This causes their slice of time to tilt. And over the vast distance of 10 billion light years, even a slight tilt leads to an enormous time difference. In this case, the alien's present is actually your past. If the alien moves toward Earth, the opposite effect occurs, their present becomes your future. This means that your past has never truly disappeared, but coexists alongside your future. What we call time is merely an illusion.